Hey guys, so the next video we're going to use Ohm's law and a parallel circuit to describe what happens with current and voltages in a parallel circuit. So I'm going to draw this battery on this side this time. I'm going to make it a 12 volt battery because it's fairly common in automotive applications and whatnot. Alright, so we have this going here. Now, sorry about the drawing here. It's a little bit crazy, but hopefully it will do the trick here. Alright, so we have R1. Now I'm going to make all of these numbers, if you just remember Ohm's law, it's V is equal to IR. And then we have I is equal to V over R. So what you're going to notice is I'm going to make all of the R's a number that we can easily take 12 and divide it by that number. Okay, so R1, we're going to make 4 ohms because that fits into 12 evenly. R2 is going to be, let's make it 6 ohms. And the last one we'll make, let's make it 24 ohms. That will work out okay. Alright, so what I want you to do here is think about what's happening. So what we have these 3 resistors. And if you look at this point right here, and this point right here, and this is wire here. I know it's a little bit scribbly. So what you can do is you can draw a path from this resistor all the way back to that side of the battery, and you can go from the other side of the resistor all the way back to the battery without hitting any other resistors. You can do the same thing for this one, from here all the way back, and from here all the way back. So from that reasoning, we are going to conclude that each resistor has 12 volts. So 12 volts are applied to this one, and this one. You need to accept that. So what we've just basically learned is that the total voltage in a parallel circuit, remember in a series circuit we added the voltage? Well, this is different now. It is equal to V1, which is the voltage drop here. It is equal to V2, which is the voltage drop here, and it is equal to V3, which is voltage drop here. So in a parallel circuit, all the voltages are the same. This is very handy. If you look at how a house is wired, all of the plugs are going to be in parallel. That means that every time you plug something in, it gets the same voltage as everything else in the house that's plugged in. Alright, so in a parallel circuit, all the voltages should be the same. Now that's to each branch. If we have more than one resistor in here, we can't then say that those 2 resistors in there are automatically going to have the same voltage. But for a simple one like this, each branch has the same voltage. Now, what we can do here is we can, even before we find the overall resistance, we can find the current that flows through each branch. All right, so let's go ahead and find I1. I can do this directly because I know the voltage and I know the resistance. So I1 is equal to V1 over R1. V1 over R1. V1 is 12 volts because, well, everything's 12 volts. So we're going to go 12 over 4. And that's equal to 3 amps. I2. I'm going to skip right to the numbers here. So that's going to be 12 over 6, which is equal to 2 amps. And then I'm going to go to I3. That's equal to 24. Oh, sorry, it's not 24. It should be 12 volts again over the 24 ohms, which is 0.5 amperes. All right, from here, what we're going to do is we're going to find the total current. Well, how do I know that? Well, the total current, we can just get this time by adding up all of these answers. We got 3 amps there, 2 amps there, and 0.5 there. So in a parallel circuit, the currents add to the total. So we have basically IT is equal to 3 plus 2 plus 0.5, and you get a total current of 5.5 amps. Great. So now that I have IT and I have VT, I can actually just use Ohm's law to find the total resistance, which is kind of nice. We don't actually always have to use the formula. I'm going to anyway just to confirm, but I'd like to show this to you. So you got RT is equal to VT over IT. That means that RT is equal to 12 volts over the, what's the current? 5.5 is our total. Now, 12 divided by 5.5 is equal to 2.1818 ohms. So we're going to go with 2.18. I think it repeats, but we'll just leave it as that. So that's our total resistance, is 2.18 ohms, which makes sense because 12 divided by about 2 gives us about 6 amps. So that's 5.5 amps. So that seems to work out. Now, let's show that we get the same answer if we go ahead and find RT the other way. Now, in parallel, we do this whole 1 over thing. So we're going to go with 1 over 4 plus 1 over 6 plus 1 over 24. Now, because I picked the numbers the way that I did, all of these should have a common denominator of 24. So I'm going to times this one by 6 over 6. I'm going to times this one by 4 over 4. I'm going to leave this one the same because it's already 24. So I'll do this in blue here. So we get 6 over 24 plus 4 over 24 plus 1 over 24. Now, when you do that, you should get 11 over 24. So RT equals, 1 over RT is 11 over 24. RT then equals 24 over 11, which I will double check. You get the exact same answer. You can confirm that on your own calculator if you wish. You get 2.18 ohms. All right, so that because we got the same answer, it basically validates what I told you about the resistances. Okay, so the resistances and the voltages being the same, and how to find resistance, how you can do it 2 different ways now. All right, I think that's enough for this video, except for one more little thing I want to show you. Notice how the biggest current was through R1. It had 3 amps, this one had 2 amps, and this one had only half an amp. I need you guys to really get the picture here that the smaller the resistance, the more current will flow. Okay, so we had the smallest resistance had the most current, and that's how that should work. You can even look at that from this. The smaller R gets, the bigger the current gets. All right, thanks for watching.